In this tutorial, we are trying to use the GTD solver to solve the problem and also understand the creeping effects using the GTD solver in NewFASANT. Let us understand the background of the problem. I'll be opening the FICO session so that we look at the problem that we solved in FICO, and the same problem will be setting up in NewFASANT. You see here we will be having a dipole antenna and also a sphere. Both the dipole antenna and the sphere were located just above the ground plane. And we are trying to solve the far-field patterns and understand the creeping effects of the sphere. And in this case, we solved the problem using MLFMM and facilitated UTD, the one of the asymptotic solvers that are available in FICO. And also, we would like to set up the same problem in NewFASANT and see how the results are agreeing with FICO results. Okay, let me go ahead and set up the problem in NewFASANT. Here we have the GTD solver. Let us select the GTD solver in NewFASANT. And the first step is to set up the ground plane for us. Here the frequency of operation is 1 GHz. I would like to create the surface first. Surface is ellipse, and we have the ellipse. I would like to choose the ellipse, and my radius of this particular ground plane is 100 times 0.3. That is nothing but that is 100 times lambda. Similarly, radius along y direction is 100 times lambda, and I have a sphere. Let me create a sphere. I have a sphere of 8 times lambda. That is the location of the x coordinate. Similarly, y coordinate is 0, and my z coordinates is 5 times lambda. I just approximated my wavelength 2.3, and the radius of this particular sphere is 3 times lambda. Okay, then I would like to have my dipole antenna in front of the sphere. I can go to the antenna over here in this particular ribbon, antenna group or antenna tab, and there I can find my dipole antenna. Okay, I can just select the dipole antenna over here, and I can choose the dipole antenna is located exactly at 5 times lambda. That's nothing but 1.5 meters, and I can select save. You can have a close look at over here. That's the dipole antenna which was located over here. Once I have my dipole antenna, I can go to the simulation parameters. I can set up the simulation parameters for this particular problem. What I want in this particular thing is I would like to have the far field, and my frequency of operation is 1 GHz, and number of bounds is 2, and direct reflected rays. I also would like to have the creeping waves. You can request other things as well. For the time being, I'm interested in the creeping effects, and also in case if you wanted to analyze the ray information, you can also activate the ray output ray tracing and save this particular thing. Once we have these things set up, then we can go back to the output and look for the output far field outputs. Actually, here in the observation, what we are looking at, number of cuts we can choose 1, and initial cut is 0, and final cut is 90. Similarly, number of points are 91, and initial point is 0, final point is 90. Once we have all these things, yes, we have the observation, we have the inputs and outputs, everything is available. Then we can go to the meshing, and we can ask to mesh this particular model. As I have 8 cores, I can use this particular 8 cores to mesh this particular problem. To save some time remeshing again, I just would like to go ahead with the calculate option and execute this particular thing, so that it will take care of both the things and save some time for us. And calculate 8 processes over here. I would like to choose all the processes on my computer and then execute this particular problem. Okay. Oh, this is not meshed. Let me mesh it first, then we can solve the problem. Sorry about that. I think we have to mesh first, then we can go ahead and calculate the mesh. Calculate for the output parameters, and it will take approximately some 30 to 40 seconds to finish our simulation. And once we have this particular output, we can open our results, and we can look into our far field patterns and also some of the rays, the flipping rays or something, what we requested in our simulation tab. We can look into all this information. I think we are almost close. Once we are done, we can look at our output information of this particular problem. Yep, we are almost close. Yes, we are done. It took approximately 42 seconds to finish this particular problem. Then we will go to the show results and we will look into the lookouts. Yes, we can see over here we have all the far field patterns. Then I would like to look into the ray information. We have the ray information. You can see over here all the reflector rays and everything is available over here. Yes, this is a simple demonstration that we set up the problem using the NewFASANT GTD solver to understand the flipping effects using GTD solver. Yes, whatever the results which we obtained using far field, these results are in good